Good morning, everyone. My name is Rohan Rao, and I'm from Triple IT Kota EC second year. So today we'll be doing an interesting project using Python here. We'll be importing an image, and then we'll be marking some points, coordinates actually, on the image, and then we'll be storing the image in a Excel file, as well as find the maximum distance between all the 500 points that we'll be marking, and also we'll find out the time executed by our program. So let's start. So first of all, we'll be doing this project in Jupyter Notebook because there's more sequential, and since there are 6 to 7 steps in our program, so we'll be giving each cell to one step. Also, we'll need few packages that are very prime packages that we'll be using in our code. Those are OpenCV and XLWT. So OpenCV is a very popular Python package that is used for machine learning and image manipulation and computer vision for that. And secondly, we'll be using XLWT. So XLWT is basically package that helps us convert Python data into Excel sheets. So basically, we'll be storing the X and Y coordinates in the Excel sheet. That's it. So let's move on to our first cell. So here we'll be basically importing the image. For that, we'll be importing the CV2 package first and time. So basically, we'll have to pip install both these two packages. I have already installed them in my system, so I'm not doing it again. We are um, initializing two lists here, x for x coordinate and yc for y coordinate, and then a dictionary of lists. We'll be making a dictionary of lists afterwards called chord, basically for coordinates. And then we'll be defining a function called mouse points. It'll take 5 parameters, but the first three are only important: x and y coordinates and the event, which will be left mouse click. So we'll be clicking the on the image using left mouse. So this is the font basically we'll be using. And event, so we have used an if statement here. So if event is equals to cv2 dot event left button down. So when left button will be pressed, a dot would be marked on the button on the image using this line called put text. It will be of this RGB. This is the color value that will be put on the screen. The font that we have selected is this, and then x and y coordinates. It will mark the x and y coordinates and put this dot on that. And at the same time, it will append the x and y coordinates in those lists, and as well as print x and y coordinates here on the screen. And basically this is it. And then cv2.I am right, what it does is, it every single time we put a dot, this line cv2.I am right saves the image in a new file called new.jpg. So 500 times a new file called new.jpg will be saved, but there will be just one file at the end that will be the last after the last point. And this cv2.im show is for showing the image. And this is a function that will be called using these statements. So basically, img is equal to cv2.imread. And what we are doing here is we are reading the image. The image we have named is lena.jpg, and cv2.imshow is another function that helps us show the loaded image, and it takes two functions. Image is the window name and img is this image. Then we'll do a set mouse callback. What this does is it calls this function above, and then we'll have to. This is a very important keyword, cv2.wait key. What actually happens in cv2 is that when we open a window for video or a image manipulation, what happens is the window just open once and it closes. So basically, we for making it stay there, we have to uh, use this sentence cv2.wait key 0. So what it does is it waits for the user to press a key on the keyboard or mouse or the cross button, so that, and for till that time it will remain there on the screen. So this is the first step of our program. We are through with the first step of program, and then we in the second step, what we'll be doing is whatever the data we have collected of the coordinates, we'll be storing it in an Excel file. uh, the Excel file will be stored as coordinates CDINTS, coordinates short form for coordinates dot XLS. We can store it as CVS or XLSX, but I've just stored it in XLS. It's my choice. And then we are importing XLWT first. First of all, we'll have to install it. It's already installed, so we are just importing it here. And also we have put the start timer here, so it will start noting down the timing of our program from here, because the main algorithm starts from here. So we have put it here, and then we'll be opening a sheet, first a file in Excel WT, and it'll dot workbook. The name of the file will be this, and we'll also be opening a sheet called coordinates in that Excel. And these two lines are basically for writing the all the um, coordinates in the cells. So what this is, a for loop actually. What it does is, in the one is actually the name of the column. So the column is B1. So from B1, what it does is, column wise, it just prints and stores all the x coordinates in B column. And what the second line does is 2, basically is 0, 1, and 2. So the third column, in the third column, I'm storing, in the column C, I'm storing all the y coordinates. So it's just simple as that. And then this book.save is actually saving it, saving the entire file. And this is also the same thing. And this is the second part is done. In the third cell, what we have done is, we have basically just run a for loop, and this coordination, the this we have by mistake initialized it again, this coordination dictionary. Anyways, what we are doing is, this is a for statement for ij in zip. What this zip does is that it allows us to iterate through two lists at a single time using two variables. So this is a very important and useful uh, for function in Python, which we don't see, or it's hard to execute in other programming languages. So what basically we are doing is, we are just storing the list of two elements in these dictionaries. We'll just keep on adding the x and y coordinates here. Next is import math. It's also a function that helps us do all this square root and stuff functions. So it's basically there in Python. We are just importing it. We don't have to install something for this. And we have created yet another dictionary called dist. What this will do is, it will store the distance between all the points. Like the 500 points, if we'll be choosing 500 points, so it will be storing all the 500 points, and the distance between all the 500 points. This is again a loop that we have been asked to design an algorithm. So what I'm doing is, basically this is just the most normal algorithm. It'll take a point and then find the distance with all the points of it, and then again take another point and then find the distance of all the points. So it's the most basic algorithm that we have used. It's simple. We have just run two for loops, for I in coordination dot items and for j in coordination dot items, and we have applied some basic maths here using the formula root x1 minus x2 whole square plus y1 minus y2 whole square. And then we have also stored it in that distance dictionary that we have created. We have stored all the distances. What we have done then is, this x we have created, and we have sorted it in reverse order, that is in descending order. And this y is storing the highest. Y is equal to x of 0. Since it is sorted in descending order, so the x of 0, the first element would be highest. So now we know that the first element is stores the distance between the farthest point. So we have the distance now. Now since we have the distance, we're running again a for loop. What this for loop does is, it matches the distance between the coordination dictionary and the y that we have just stored, which is the maximum distance. And when there will be a match, it will note down which 2 points that we have taken. So there is a match, and then this breaks the statement. As soon as there is a match, we don't have to check for any other points. We are just storing the points as P1 and P2. and we are printing both of them. So this was the most critical part of the program where we have to do all those maths and algorithms, and then in the end we'll be left with two coordinates, p1 and p2, that would be that would be storing the maximum. Those two will be the one with the maximum distance between them. So so this is the sixth part. What I just told you. Here, what we are doing is we are printing it, but it's in the form of a string, and it's just we haven't found it yet. We know that these are the points, but we have to store them in another variable. This is the Suppose we know that this is a point one and point four. Okay, so this cell is again very important. So in the last cell, what we did was we found out the points P1 and P2. That is, suppose the point is point 2 and point 253. So we know the 2 points. But now, since we know the 2 points, so in this what we are doing is we are finding the coordinates of those 2 points, K1, K2 and L1, L2. So K1 comma L1 would be the coordinate of the first point. Suppose the first point is 1 itself. So K1 comma L1 would be the coordinate of the first point, and K2 comma L2 would be the coordinate of the, suppose, 500th point is only the last one. So it will store the coordinates of that point. So we have again used a for loop, and we have, when there will be a match in the coordinates, so K1 will be storing this, and L1 will also be storing this. Similarly, K1, K2 and L2 too. So in the end, we finally have the coordinates of both the points. So why do we need the coordinate of both the points? What actually we have to do is that we'll have to draw the line between both the points that we have found out. So we need the coordinates. So for drawing a line, again, OpenCV will be using. It's a very vast library, so there are many things we can do it with it. So again, image manipulation is one. So we'll be manipulating an image by drawing a line on it. So again, we have imported this. We are reading this image new.jpg, since we are not importing the lena.jpg, because lena.jpg was the one where the points were not stored. But this new.jpg is again where the points that I have marked will be stored. And then we are creating a copy of this because we don't want to hamper the old image. And by this line, we are actually drawing a line on the coordinates here. So we know the coordinates are k1 comma l1 and k2 comma l2. So we have mentioned it here. We have also mentioned the image where we'll have to draw the line, and then we'll have to mention the color and the font size of the line, and then we'll be showing the image. We are showing the image, and we have just written draw line, so it is basically just a name given to the window that will appear. And what this does is that it'll it's just a way to call this. This is a parameter that will be this is a necessary parameter that for this I am sure. And then again, wait key for waiting, as I have told above. And this is the last part of a program where we'll be finding the execution of the program. Since you can see here end, and we also told you that there was a start ahead. So this last part, we have this end. So end minus start, what it's doing is end minus start. So basically it records the starting time and the ending time, and this um, basically subtracts them and finds out the execution time of a program. So this all these data is what you're seeing is what I was doing the testing myself. So these are the data from this. So we'll actually be doing the testing again in front of you. So, we'll be we'll be restarting all the cells, and then we'll be showing it. For that, for showing you the screen, I'll let me present my entire screen. Okay, so my entire screen is being presented right now. So execute this and we'll run all the cells. So the first cell is run and we have imported this image. So this is basically the lena.jpg that I have imported. So what we'll be doing is we'll be writing, my roll number is 2064. So I'll just write 2064 using dots here, and there'll be 500 points. So these are the dots that are appearing on the image. So basically I'll be writing 2064 using this blue dots, and I'll just account for it. There'll be like 500 points. This is going to take some time. Okay, so we are done here. As you can see, 2064, we have plotted 500 points. We have written this 2064 using plotting 500 points. And now you'll see, as soon as I close this window, the distance between the line between the maximum 2 points would be shown here.
And you can see that the distance between the maximum points are here. So this was the maximum point and this was the point here. So this is the maximum point between the distance between the maximum points. As you can see, I've changed the color here from blue to red, so the lines are visible here. And this completes our main part, that finding the distance, that we have done using draw line and OpenCV commands. And next, also I'll like to show you the CDINTS, the coordinates that I have. There are 500 coordinates here that we have done using that package. The B and C cells are holding the X and Y coordinates, and the 500 points are here. As you can see, I'll scroll down, and these are up to 500 points. The values are stored. So all the task has been done, and only the last task is left. That is this last part, time of the execution of the program. So, and this is the last part of the program. As you can see, this the execution time of the program has come to 1.041 seconds. So our program has been completed. We What we did today was we found out the coordinates, stored it in an Excel sheet, and using OpenCV we drew the line between the maximum coordinates, and also we found the execution time of a program, which is 1.04 seconds. So thank you.